All right, so chapter one, we're going to basically talk about like what is Java and some very basic things. So back in the day, 1991, a really long time ago, um, they had this task to develop a program for handheld systems, and basically they were going to use C++, but it didn't do what they wanted it to do. So they actually created Java because of that. So that's why there's some similarities because Java is based on C++. So you'll see a lot of similarities, but then there's some things they changed, right? So there's going to be some differences. So actually Java was first named Oak because there was an oak tree outside when they were trying to come up with a name, but that name was actually already copyrighted. So then they're drinking coffee and they came up with Java. So James Gosling was the one mainly responsible for creating it. And actually, he was like, we might be able to get him for a talk one time because one of the classes had him speaking on Zoom. So I'd really like to do that as one of our events. So if I can, that'd be great. So I think that'd be really nice. Now, when it first came out, the browser, HotJava was the first one to kind of say Java enabled browser, but I don't know of any browsers now that aren't Java enabled. It pretty much comes with your browser. And then it automatically updates for you unless you turn off the settings for it to update, automatically updates. So if you ever see that little coffee cup and it says something about a JRE, that's a Java runtime environment. That means that whatever you're doing has Java. So Canvas, I don't know what language Canvas is written in, but Blackboard is written in Java. You may have good or bad experiences with that. Um, but there's lots of things that you may not even know are Java that are on the internet. The only thing is we're not doing Java for the internet in here because it's required that you know some HTML and you know some things outside this class to do. So we're only doing applications. So applications are standalone programs for your computer. So we're not going to do, but you can always go into that in the future if you're interested. So Java, one of the great things about it is Java is like a write once, run anywhere language, they call it, because basically you can write it on any operating system and then you can run it on any operating system. And so that's not true of all languages, but it does require like a middle step in there that kind of slows it down a bit, some people say, because when you actually compile your code, it creates something called a class file. And the class file is what will run, but it's not quite machine code. So then you can take it and use it on any operating system. It will convert it to machine code and it'll run on that operating system. So that's the cool thing about it, but then it kind of slows down, you know. People have everything has advantages and disadvantages, right? But Java is known for, being cross-platform. So you can run it and write it on any operating system. Why can't I just okay. So hopefully you heard the term IDE before, editor. That's your integrated development environment. We just call it editor. You can, again, use any one that works for you. NetBeans and Eclipse are big ones. You can use, there's some smaller ones like JCreator. That one I think there's a cost with. IntelliJ, a lot of people like. Students really seem to like VS Code. VS Code has a lot of flexibility for like there's a lot of things you can add enhancements. You can change like the color coding scheme and add like, I know some people told me like, oh, I got like the cat code. Like, I'm like, okay, whatever works. You can, I don't use it, but my students seem to like it. I've seen it. It is pretty cool. It is nice because you can do multiple languages. So like if you want to continue to use it, you can use it back for C++, or I think it does Python too, Java. So that's kind of cool about it. The only thing NetBeans also does it, but NetBeans is really clunky working with C++, I think. To try to get it work with a C++ compiler isn't as easy as doing Java with it, I found. But you can get NetBeans to work with other languages as well. So you have to pick what works for you. You're going to need a JDK. Now, some editors you install will come with the JDK. NetBeans, you're going to have to install it and then install it. Most of them you have to install separately. You may have a JDK if you've written any Java code in the past, but you may need to update it because every, so many months they come out with a new version. Now, there's not usually major changes to like the new, but there is from like we're on like version 18 or something. So if you have like version like 13, that would be really outdated. You might not have some of the new code that we talk about. So you just need to make sure you do update that, but you probably don't need to update it if you have one in the last year or so. Okay, Java virtual machine. If you install the editor like NetBeans, it comes with a Java virtual machine, which means that whenever you compile your code and you run it, the Java virtual machine actually runs your application. So it comes with that automatically. That's what actually converts it from the bytes code to your machine code to run it on your machine, depending on what operating system you have. Okay, so we write it in, we're not going to write it in like Notepad and like a basic text editor. I'm not going to make you do that. Like if you want to practice that in the future, you can. But like they wrote these IDEs for a reason. They're useful. Back in like grad school, I had professors that like were like, no, you will write it in Notepad. No, I mean, there's a reason why they're there, right? Why make life difficult? So then you're going to compile your Java code. So you're going to have your Java code that you're writing in your text editor. And when you compile it, it's going to create a class file. Okay. The class file is what runs. Okay. So technically, if you were to give me your class file, I can run it and see what your application does, but I can't get your Java code from your class file. So you need to give me your Java code because I need to see how you wrote it, not just that it runs. So I don't want your class file because I can get your class file by running your program because I can't see your code. I can't see if you put comments in it or how you did it. So I need to have your Java code, not your class file. Okay. And then the Java virtual machine will take that class file and it will run your application. Okay. So this is a very basic sample program. You can see Hello World. You probably did that in C++. That's like the first thing you do, right? So you can kind of compare it. The comments in Java are the same as C++. So you start with a /*, and then all those extra little asterisks are just because I thought it looked nice. You do not need those. So the /* here and a /* here to stop. Okay, you don't need all this extra. But I do want you to write your name and the date at the top of your program and then a brief description about what it is. I also like that you write the JDK version because depending on JDK version, that will affect how you write your code. So I think that's important to have at the top. Now, every Java program is going to start with public class and then a name. The name is going to be the same as your Java file, except it doesn't have the .java on the end of it. Okay, but it has to be the same. So if you change this, you have to change this. And if you change this, you have to change this. They have to match. Okay, now, you should start your classes with a capital letter. If you don't, will it still work? Yes, but you should start your files and your classes with a capital letter because it's just a standard and it looks weird if you don't. Okay, now you cannot put spaces between your name. Like I can't put hello world space with space between hello and world. I can put an underscore if I want to, but I can't put a space. Okay, you probably learned some naming rules in C++, hopefully. No spaces in any of your names ever. Okay. And then, what we're going to have is a curly brace to start and a curly brace to end. This is a single line comment, which hopefully you learned in C++, looks the same in Java. It tells you what that line does. So it tells you ends the program. Do I need to have that? No, that's just a comment. You don't have to have it. But whenever you have a starting curly brace, you're always going to have an ending one. And so you can think of it like this is your class from here to here, and your code is going to be inside your class. Okay. Now your class is also, you can kind of think of it as like your file, like this is your program that you have. Okay. And then indented in there, you're going to have your main. We call it a method in Java, not a function, but you called it main function in C++. So you have main. Main looks a little more complicated in Java than it does in C++, but you will get used to that. The cool thing about NetBeans, when we get NetBeans in here, is whenever you start a new Java file, it will automatically put that main in there for you, so you don't have to type it word for word. Now, you will not understand all the pieces of main right now because we haven't talked about methods in here. And so it's really hard to explain what static means since we haven't talked about objects or anything like that yet. But by the time we get to methods, you should understand all the different pieces of that method. But for right now, we're just going to write it like that. It's always going to be public static void main and then string args in there as the parameter. And we're just going to write it. We might not understand it, but for now, just know that that's how you write main. Just like when you were in C++, you probably wrote int main, but you didn't know why you wrote int. Like, just like, it just goes there, right? Like int main and in parentheses, I don't know why. And then I put a curly brace and I put a curly brace, and for some weird reason I put return 0 down the end. I don't know why, but I do, right? And then you got to functions, and hopefully you're like, that's why that return 0 is there, and that's what the int means, and okay. So it's the same thing. You didn't understand it on day one, so you just kind of ignore it. So same thing, like we are not going to understand it no matter how many times I explain it right now, so we're just going to worry about it later, okay? And then the same thing with this. We're going to kind of basically understand it, but we're going to understand it more as we start talking about things, because out is actually an object. It's actually your monitor. It refers to your monitor. System is a class. It's a file out there, and there's an object called out, which is, again, your monitor. Print ln stands for print line, which means you're going to print something to the screen. You're going to print a line. I know in C++ you use C out, right? When you want to print something, and then you use end L for end line at the end. Well, the nice thing about Java is if you use print ln as the method, instead of using like C out, it actually will start it on a new line, okay? And so that's kind of cool. If you use print, and you continue to print, they won't do separate lines. And so there is a method called print, but the print line, and that's an L, not a 1. I always have students put a 1. Print ln will put it on a new line, so it makes sure that you have new lines. But you can still use like \n. So you learned that in C++. There is no end L, like for, like in C++, but you just put inside your string, you just put \n if you want extra lines throughout, and that works just like it did in C++. So in your string, you just put \n, and that works. So a lot of things do carry over, but then it looks completely different, right? So, and then we put a semicolon to say we're finished, just like you did on the statements when you did the cout statement in C++. So whenever you wanted to print something in C++, you did cout, and then you put in quotes what you wanted to see out. So in Java, because we're using a method, we're going to put that string inside a method. So it's going to go in parentheses, and then whatever you want to print goes in quotes. Okay. And if I wanted \n, I would put, like, if I wanted this on 2 separate lines, I could put \n here. Or I could do 2 separate system out print lines. Okay, so far so good. And then your main method is always going to have an ending curly brace here. So main in Java doesn't return anything. So I know in C++ you put return 0 because it did return an integer. Main doesn't return anything in Java, and that's why it says void here. So you might remember the word void. Because it doesn't return, then you don't put any returns in here. So you don't have like a return 0. Ready good so far? You're not overwhelmed, right? Okay, all right. Okay, so we have statements that get semicolons at the end, right? Then we're going to have something known as blocks of code. So like main method is a block of code. It's a method. So remember in C++ functions are blocks of code. So you start with a curly brace, you end with a curly brace. Typically on blocks of code, we don't put curly braces like with do while as an exception, but we don't put semicolons with our curly braces. We just put curly brace to start, curly brace to end, okay, for blocks of code. Okay, these are all the escape codes. We talked about \n. You need to make sure you use the right slash. That will give you an enter because you can't hit enter in your code. If you wanted to actually display a backslash, you put 2 backslashes because one would actually signal that you wanted an escape code. If you want to put quotes, you can't put quotes inside quotes because then it thinks you're stopping the quote. So you have to actually put \quote. So I have an example here. I know it looks very strange, but like this quote tells you to begin your string, and this one tells you to end. But this one, because it has a backslash, tells you to display a quote in your output. Because if I just put quote here, it would think end string, and then this one would think begin string, and it would say like you have 2 strings next to each other and you didn't do it the right way. So in Java, you can't put like a string and a string without putting a join between them, and so we get upset. Okay, so everybody good so far? Okay, all right. You probably know this from C++. You probably made syntax errors. If you got through the whole course and you didn't make a syntax error, you're like extremely lucky, right? Because you probably just were typing and made a syntax error. So the thing I really love about NetBeans that I don't love so much about like online GDB and some of the basic editors and any full-fledged editor, I love this ability. It actually will, detect syntax errors as you go. So if you're typing a line, it will say it's a syntax error until you're done. Pretty much it'll highlight certain things. But when you're done, you shouldn't see like any red underlines. But when you're done with that line, if you see a red underline, you know there's something's wrong before you even like try to run it. And the other thing that's really nice about it is it gives you like tips for how to fix it. So a little light bulb will pop up and it'll say like, try this, this, or this, like this, which online GDB doesn't really like give you that. And so that's why I think using like a full-fledged editor that gives you more troubleshooting help, more debugging is kind of needed as you get higher in the classes. So syntax errors means that the computer doesn't understand you. You're not speaking the same language. It's like you forgot semicolons, you misspelled a command so it doesn't understand, you use wrong capitalization. So you can't get anywhere if you have syntax errors because you can't run it. If you do run it, sometimes it'll ask you like, would you like to run a previous version? So it's not the one that has the syntax error that's running. Because if you have a syntax error, that one never runs. But sometimes students will say, well, it's running and I have a syntax error. No, it's running like the previous version. It's not listening to the new one. Because the thing is, if there's a syntax error, it cannot get the new class file. And if it can't get a new class file, it can't run it. So it'll run an old class file though that it found, and so it'll run what you had previously had working. So runtime errors mean that you were going through your program and all of a sudden it crashed. So it ran and then it crashed. You probably had software that crashed before, right? At some point, that's, like if you're asking the user to enter a number and they enter a letter, it can't be converted to a number, it will actually crash. Now, C++ actually does a lot of fixing for you. So like if you forget to initialize a variable, it'll initialize it for you. Like it'll set it at 0. Or like if you go too far in an array, C++ will just grab whatever garbage is in the next memory location and give it to you. And it won't say like you went too far in the array. Java will crash and say you went too far in the array. And like, I think it's kind of cool because like, I don't think you should be able to do things that you're not supposed to be able to do. And I don't think it should fix it for you, but that's just my opinion. So when it crashes, you're probably saying, well, crashing's not good, right? Well, no, but there's actually something called exception handling in Java where you can tell it how to handle the things that are like, if it goes too far in an array, what do you want it to do? So like when it gets to that point, instead of crashing and telling you went too far in the array, would you like it to do something else instead? And you tell it that. So that's later in the class though. That's in like chapter 11. So right end. So right now it'll crash, but we should, when we look at these things, we can also, handle them and troubleshoot them. So it's kind of good actually. Logic errors mean that it didn't do what you wanted it to do. It ran, it never crashed, but it didn't do what you wanted it to do. So if you put in the wrong equation, you get the wrong answer, that's a logic error. So we know in math, just because we got an answer, it's not right? Or it doesn't have to be right all the time. Just because it's nice to get the answer, but it might not be the right answer. So it's the same thing. If you put the equation and you put parentheses in the wrong spot or you didn't put it correctly, it will calculate it incorrectly. And so you have to say, that's not right. That doesn't make sense. So you have to test it. So we're going to make sure we're testing our programs with different data to make sure that the output that we're getting is reasonable for what we're asking. Okay? Okay, so we have to make sure, now I am going to get to a point where I start collecting this, but at this point I'm not, so I'm hoping that you're doing it. So part of software engineering is thinking about what you're going to do before you do it. So I try to do that when we're doing our programs. Now, when we're first starting off with like Hello World, there isn't a whole lot to think about. You're trying to print Hello World to the screen. So really like the pseudocode is we're printing Hello World to the screen. So it's not, so as we have basic programs, but as we get more involved, we need to think about like what part do we want to loop? Like what part gets repeated? You need to think about that before you code, because if you're not thinking about it correctly, then you might have to go back to the drawing board again and you wasted a ton of time coding. So pseudocode is really helpful whenever you get longer programs and you're trying to think about what are you trying to solve and how are you going to solve it. Now, it doesn't matter like how you write your pseudocode. It's just English way of you jotting down ideas. It can just be like a quick diagram of what you're trying to do. It could be as simple as like input and then whatever calculation, output. So you remember, like, I have to output it or I won't see the answer. Just some basic notes for you as to what you're trying to achieve and how you're going to get there. Okay. So that's like the designing, writing. We have the pseudocode. Then we have debugging. So, sometimes we may do it 100% correct, right? But we still need to test it. We need to test it with different data. And if it doesn't do what we want it to do, we have to debug and figure out why it didn't do what we want it to do. And we have to go back and recode and make it work. And maybe we didn't think about the problem in the right way. We need to redesign it. Sometimes you have to go back, redesign, recode. You might have to redesign things. Documenting. Again, when we first start off, it's not as important because it's very basic. But as we get more complicated code, you are going to want to comment your code that says why you did what you did, or, because when you code, you're not going to be working in a bubble by yourself. When you see these video games that people have done, have you ever seen the long list of, like one person might just be in charge of the sword for the game, okay? Because it's complicated, right? It's not like one person wrote those video games, right? They weren't just like programming all day and all night to write this video game. It's like, even like Angry Birds took a lot of people. It's not just like one person, right? Even these apps are usually multiple people. So you're coding with other people. You're just not doing it by yourself. And so you may know how you did it or why you did it, but you need to tell other people. Like if it's a really strange way of doing something, maybe you tell them why you did that. Or if it's something complicated, explain why you did it. So somebody else looking at your code knows, yeah, that makes sense. Or they don't have to sit there and wonder, what? When they're looking at your code, because they're going to have to integrate their code with your code. And if yours doesn't make any sense, then that becomes more difficult. So documenting is important, letting people know this is what this method is about. Now, we also, in this class, will start writing our own documentation. So like when we're writing methods and such, we will actually be able to produce like an HTML file that tells like all the different methods, the documentation for what our methods do, what parameters it has, what does it return. So that's part of documentation as well, letting people know what your code does. Okay, and maintaining, of course, you know, things get outdated, so we have to go back and maintain. Okay, so we have to think about what our interface looks like. We're not doing much with interface here. It's either going to be like in C++ where you just have like a little prompt, or you're just gonna have a message box. We're not designing like a whole graphical interface in here. Okay, procedural programming. So when you did your C++ class, you actually only did the C portion of C++. You actually didn't do any object-oriented, which is the C++. So technically C is procedural language. When they added the other components, that's where the language C++ came in, but you actually didn't do any of the C++ because that's the object-oriented portion. So C is what came out first, and then C++ is like the upgraded. There is no C+. So just, but if you remember the whole like plus plus means add one, C++ is the new version of C, but you actually really didn't do the new components of it. But it does do object-oriented. So if you did want to like learn C++ object-oriented after this class, it would be good and similar to what we're doing in here. So, but you'll see C is on there, but not C++. And then Fortran, these outdated COBOL, these like, so procedural are all the things you did in your first class, okay? Now, Java is hard because Java is object-oriented. So as you already saw with the very basic printout, it's using objects. You cannot really do Java without objects. You can't even start with printouts without objects. Java objects are integrated into everything you do. So we're going to have them, but not really talk about them much until we get to a chapter on that. I believe it's chapter 6. So we're just kind of like this is an object, but I don't quite understand it, but I'm going to understand it later type thing, because Java, you just can't do without objects. It's part of it. But C, you can, right? You didn't use objects in C. But Java, you cannot. C++, C#, Python are all object-oriented. Okay. And so that's the main part of this class, this object-oriented. So we're eventually going to make it there, but we have to go through some of the other content first to get there. So what I want you to do is I want you to go to your browser, since we don't have NetBeans in here, unfortunately, yet. I wanted to use NetBeans, but we will do this. We're going to go to Online GDB. And Online GDB allows you to select Java as your language. You can make that bigger. You can also just kind of collapse this. I won't really use Online GDB after this once I get NetBeans installed, but you can for the beginning part, but we eventually want to transition away from this, okay? But for the first part, it's okay. Okay, so basically it already has what I want in there. It starts with like a template. That's what we kind of were wanting to do. I don't need all that stuff at the top that tells me what Online GDB does. That's where you would actually just put your comments, and it already has it set up with the slash and the asterisk. Hopefully you remember that from C++, that's a multi-line comment. But really, you don't even need all those extra asterisks. If you kind of backspace that, you just need to put slash asterisk, and then you'll notice everything becomes a comment, right? So I have to finish it. But then if I type my name, right, and then I hit enter, and I can put it, you know, indented to make it look nice. Today's date is the 26th. Can write today's date. I'm not going to worry about the JDK right now, because that's easier in NetBeans. And actually, you can say about, and it'll tell you which JDK. We'll worry about that next time when we get NetBeans. But we're going to see print hello world to the screen. So very basic description. And it doesn't matter if you put the asterisk slash on the same line or the next line, whatever looks nice to you. I am not picky about whether you put like an enter here or you don't put an enter there. That doesn't matter to me. That is just your preference. Okay. This curly brace is going to match up with this curly brace. Now, if you want to, you will see some people do this. You will see some people put it back on the previous line. You may have done this in C++ as well. When you did like functions, you have the option to put that up on that line. A lot of people do that. Some people like to put it on the next line because then it lines up with the next one. It's really up to you, whatever works for you. If you're confused because you're like, where does this one go? Then put it on the next line so they match up. You can see them match up there. When you click on them, they should turn green here. They'll turn colors in NetBeans too, so it's kind of nice. You can see that you have one opening and one closing. Okay. Now you can see this one actually has the curly brace up here with main. So you can put them down like that if you want to, or you can put it up with the method. It's really up to you. It doesn't matter to me. Some people like to condense it in the least amount of lines as possible. Whatever works for you. Okay. This is going to be the same each time. And as I said before, it's not going to, there's no reason to look up what each of those words mean because we're not going to understand. You probably understand void from methods. The public and static are new to Java, not from your C++. You didn't talk about public and private or whether something's static or non-static. So that's a new Java thing we'll worry about later. The string args is an array. We're not going to talk about till later because we haven't talked about arrays, but so that's just going to be that way. We don't have to know why. And then this is indented. This should be indented automatically. Then this should be indented. Okay. And you should notice that some of like these orange words are like there's different colors orange. I don't know if you can see it up here, but these are like your keywords. Okay. And then this is a different color. It'll be different color in NetBeans, but this is your comment. And then this is strings are going to be green. But there's no point in learning the colors in here because it's going to change when we get to any editor that you use. But so if you go ahead and run it in online GDB, if you want to run it, you just hit this little green run button here. And it should go ahead and print hello world to the screen. Okay. And then if you change it, if you say like, I really want to put an exclamation point here and then run it again, it should put an exclamation point down there. So you have it. Okay. And then if you want to do another line, you have a couple options. So you can take this line and you can copy it. You could just add another line underneath. That's another system out print line. And on this line, you could say something like by your name. So I'll put my name, put your name in there. Okay, and then run it. And it should get on two separate lines because it's two separate print. And this is LN. Again, I know that looks like a 1, but that's an L. And so did you get it on two separate lines? Okay. If you take out the LN, just so I can show you, it will end up on the same line. So the print will print, but it'll be on the same line. Now, if you wanted to, let me go ahead and put back this LN. If you wanted to condense into one line, I was talking to you about this before, you can do a \n instead of putting two system out print lines. And hopefully you already practiced this in your C++ class. Okay. And so if you were to do that, that would look like it did before, with the \n would represent a new line. You want two lines and you just do two \n's. But you do have to be careful because I know that some people say they don't like this n up against the b, but if you hit space here, you will actually get space in your output. You see how you get a space there? Every time you hit space in here inside your string, hopefully you remember this from C++, it shows up in your output. So it's just the same in Java. Anything inside of the quotes actually is shown in your output. Okay. Does that make sense to everybody? Y'all okay with that? Anybody have any questions? If you have a syntax error, it's going to look different in here than it's going to look in NetBeans, and every editor is a little different as to what it will say. But if you get a syntax error and then you run it, it's going to tell you, sometimes it'll tell you exactly what's wrong, and sometimes it may not be 100% correct, but you have to figure out from what it told you what you think might be wrong, look at that line or look at the previous line and see if there's something that could be wrong. You have to be really detail-oriented when you're programming. You have to make sure that everything's capitalized correctly, there's all the right punctuation, you didn't miss a period somewhere, a semicolon, a quote. So this one's pretty easy error. This is what I'm talking about, like on the go. Whenever I make a mistake in online GDB, it doesn't tell me that I did. Now I can use the color coding to determine that that doesn't look right because it's not the same color as it normally is when I use it. And I'm saying that looks weird, okay, because the color coding's off. But it doesn't come up with an underline and say there's something wrong with this. That's what NetBeans is going to do for you. I wish I could show you that. I will show you next time. But you have to like look at the color coding or you have to run it to determine that there's a problem with that in online GDB. And that's why we're going to get away from online GDB because the debugging in online GDB, really isn't as good as like a full-fledged editor. Okay, so here it's telling me, it tells me I need a parenthesis, which is not correct. It's just really confused by that. So then don't go add parentheses. If you see that like you have the right number of parentheses, don't go add things just because it told you, because it's not always 100%. So you have to say, okay, what could it be? And go through everything here. And hopefully you'll notice the color coding's off and that there's a quote over here, but not over here. It depends on what type of error you make, how easy it is to determine based on what it comes up with. I believe in NetBeans, if you forget the quotes on a string, it tells you like unclosed string literal. So if you know what a string is, unclosed means you forgot. It doesn't say like missing quote, but it says like something similar. This one doesn't give you what it should give you. That's why I'm not really a big fan of using this for this class, okay? If you misspell something, that's a logic error, right? So you probably don't make those before because you're like, oops, that doesn't look right. Or I get a lot of students that, you know, accidentally forget the backslash n and it runs into each other on one line and you're like, that doesn't look nice. I need a backslash n in there. A lot of times spacing doesn't always look like what we think it should. And then we're like, we need to fix this. Those are logic errors. Okay, but that should work now the way I want. Everybody good with that? Okay, so I think if I go to the exercise here, there are 2 exercises. So for chapter 1, there are usually 2. Sometimes there's 3, depending on how long of a chapter it is, but this one's pretty easy. This is this is what we just did as your first exercise, super easy, right? So all I need from that is your Java code. So you will just upload 2 different Java files, the Hello World one and then the triangle one. So if you want to submit this right now, since you have it, that'd be great. So right here, you can actually download. Now, it automatically saves it as main.java. You can go to settings over here and change it. And if you go to settings, you can go to downloads, ask me what to do with each file. So you can then save it with whatever name you want, or you can just right click rename it, you know. But then I can also pick where I want to save it because it goes to downloads folder if you leave it as the default. So I like that because now when I do it, it should ask me, when I say save as, I can pick desktop or I can put it on my flash drive, and then I can also choose a different name for it. Now, it's not going to match the class name I have here. That's okay because we're using online GDB. When we do NetBeans, it will match and everything. But for now, that's okay. We're just trying to turn it in for, you know, getting credit for it. So I don't want, if you have a folder and all of them, you know, are called main, they all replace each other. So you're going to have to give them different names. And besides main. So, so that's your Hello World one. And then you can go ahead and upload that. And then this one, I'll have you do on your own. Okay, and you know, some of you are going to work faster than others, so you might be able to finish that today and turn it in. I basically want you to draw a triangle with the little asterisks with the printout statement, so it's practicing spacing, because you can see here that you have, unfortunately we don't have NetBeans, but in here online GDP, just to do this should be easy enough. We're going to put the quotes and put some spaces so that they can line up differently, so they have different number of spaces and different number of asterisks. And then it should look like this whenever it's run, when you run it. And you can just save this one as triangle. I usually try not to save my exercises as like chapter 1 exercise. You can do that, but I want you to, when you're doing the checkpoints and everything, I want you to be able to go back and like reference exercises, and you might not remember what the chapter 1 exercise was, and you have 2 of them. So you have to be like chapter 1, 1 exercise, chapter 1, 2. You know, you might not know what it is, but you'll probably remember the triangles with you drawing the triangle, or Hello World. You probably won't ever need the Hello World one again because it's very basic. But as we get more involved and we're doing like a guessing game, if you call it guessing game instead of like this exercise for this chapter, then you can remember hopefully, oh, in the guessing game, I used like a random number and I need to know how to do that for this. So I'm going to go pull that up. Hopefully, if you give them more meaningful names than like chapter 1, this exercise, if you call it something, it's really for your benefit. If you call everything like main 1, main 2, main 3, like because it came from here, you won't know what they are when you're looking at them later. Same thing with the assignment. If you just call them like assignment 1, assignment 2, you probably won't remember what like assignment 2 is. But if you give it a name that's more meaningful with the assignment, like what am I asking you to do? Then hopefully you'll know, like, is this going to help me with this checkpoint or what I have to do for the assignment? Well, I guess if you're doing this, I'm not, but you know what I mean. Like when you're doing the checkpoints, would this be something helpful or for a future assignment? Is everybody with me? So really the naming is up to you. It doesn't matter to me what you name your files. But it's going to be helpful for organization purposes. When you go back, you can say to yourself, I could use this. And if you separate it based on chapters, and maybe instead of calling it chapter 1, chapter 2, maybe call it like intro, variables, conditionals, loops, so that you go, oh, these are the looping examples. And then that way, you know, like when on the checkpoint, you need to go, you might forget what chapter that was in, especially on the final one. You can go look it up. Whatever works for you. Okay. Does anybody have any questions?
So for the assignments, do you need us to comment or no commenting needed?
So I believe I give you comments for like the beginning ones, like the name, the date. As we get more advanced, I think I might have put a couple throughout, but comments throughout is really up to you. But just comments at the beginning for now, for sure. I think you get like a point or two for that, but I didn't say you had to do it throughout, so you don't have to put like this line prints hello world to the screen unless you want to. Any comments you want to add to your code to remind you what it does, especially, you know, the more advanced things would be beneficial for you, but I won't be grading, so whatever works for you.